Math 8, Unit 9, Lesson 2, Part 3. Exponent rules, power of a product rule, also known as the distributive property of exponents over multiplication. Okay, on this one, 2 times 3 to the third power. This would be, using the definition of exponents, 2 times 3 times 2 times 3 times 2 times 3. 2 times 3 is going to be used as a factor 3 times. Now, if we use the commutative property, we have 3 2's and 3 3's here. Now, the 3 2's can be rewritten using exponents as 2 to the third. The 3 3's can be written using exponents as 3 to the third. And this is where we're going with that. Let's look at these other examples here. So, 2 to the fifth times 2 to the, 2 times 5 times 2 times 5, it gets written twice. So this is 2 times 2 and 5 times 5, or 2 squared and 5 squared. Notice here that every number inside the parentheses gets the exponent. This is why it's frequently, why I refer to it as the distributive property of exponents over multiplication. There's also a distributive property of multiplication over addition. That has to do with how addition's related to multiplication and how multiplication's related to exponents. Okay, 3x squared is going to be 3 squared x squared. And 5 times 4 to the third is 5 to the third times 4 to the third. Okay, so looking at this example, 3xy all to the fourth power. That's going to be 3xy times 3xy times 3xy times 3xy. Which would end up being 3 to the fourth, x to the fourth, y to the fourth. When a base has multiple powers multiplied together, you may distribute the exponent to all powers in the base. All the powers here are 3 is a power, x is a power, and y is a power. Okay, the exponent rule here. If you have xy all to the a power, you get x to the a and y to the a. And the name of this rule is the distributive property of exponents over multiplication. It's also called a power of a product, because we're doing a power of a product. The product is the base. Okay, let's look at some examples here. Because this is all multiplication inside, this is 6 to the fourth, a to the fourth. Okay, next example. The 2 is going to distribute to every power inside. There are 3 powers. 3 squared, p squared, and q squared squared. Now we've got to apply another rule we've learned previously. Q squared squared is q to the fourth, because you would multiply those together. And we saw that in the previous video to this. Okay, negative 3 to the y. That's negative 3y cubed. Negative 3 cubed is actually negative times negative times negative. It's just going to be negative. So this is negative 3 cubed y cubed. Okay, this next one, those need to be distributed. This is negative x cubed y cubed, and then x and z. Negative x cubed is going to be negative times negative times negative. I guess this is negative 1 cubed. Let me separate that out. Negative 1 cubed times x cubed. Negative 1 cubed is just negative 1. X cubed times x, those are powers with the same base. It's x to the fourth, 3 plus 1. Y cubed and z, and that would end up being the answer here. Now there is one caution that I want to give you, and that is that this distributive property does not work for addition. It only works for multiplication. If it's addition, things get rather complicated. You have to write the sum twice and then evaluate it. And you use the distributive property here, and it's a little time consuming, but it does not come out to be simple distributing like you can do with the other. So this would be x squared plus xy, and in the other one we've got another xy and a y squared. These are like terms, x squared plus 2xy plus y squared. Now the point I make here is that you cannot just distribute it and say it's x squared plus y squared, because it is not. It actually has that additional term in there. So you cannot distribute over addition. It only distributes over multiplication. Thanks for watching.